Hello, and welcome to this presentation today. It's a bit noisy. I hope you can hear me in the back. If not, just yell. My name is Bertrand Delacretaz. I come from Lausanne. I work for Day Software in the R&D team as a senior developer, and I'm also quite active in the Apache Software Foundation as a member of the board of directors. If you have your laptops, you can find the slides on my blog here. I just added one slide a few minutes ago, but it's the same thing. A few words on the company I work for. I tend to have dense slides sometimes, but I don't want to go into too many details, just to tell you that Day is headquartered in Basel on the Bertrands. It's a nice place. And a few places around the world. We're about 150, 140 people worldwide. We do large-scale content management systems for big customers, big companies like automobile makers, McDonald's, worldwide hotel companies. There's a good roster of that. We've been through tough times. This is the share price. In 2000, in the crazy years, it was a bit higher than it is now. But we survived that, so we know about crises. We support very much the Apache Jackrabbit and Sling projects, which Jackrabbit is a JCR content repository, and Sling is an application layer on top of that. And we have Roy Fielding, who's the inventor of REST and the co-author of the HTTP protocol, works for us. He's our chief scientist. And David Nuschler, who's a spec lead for the JCR, Java Content Repository, spec works for us as well. Just to give you an idea of the company, and I'm done now with the company stuff. The talk is about how to use the right collaboration tools in the right way. Based on our experience, my experience in open source projects. I've been active in the Apache Software Foundation for about nearly 10 years now. And we use those tools, Subversion for source code control, Jira for issue tracking, Continuum or Hudson for continuous integration. And my angle is how do these tools enable efficient working as a team, can be open source or not. Our company sells, our final products are not open source, we sell them, but they're fairly thin layers on top of open source stuff. And so I'm happy to talk with you about that later if you want. Because I know, this is an open source conference, so don't kill me right now. But our products are not open source, yet inside the company we work very much in the open source way. And we are very active and supportive of quite a few open source projects. And the question is there a secret sauce? Having the tools is fine, but how do you use them? In the Apache Software Foundation, I don't know how many of you are familiar with the ASF. It's become quite big over the years. We have 2,000 committers now. We have more than 60 top-level projects, about 500 members of the project management groups, 300 members of the foundation, which take care of the foundation in general. So that's quite a big thing. We have no offices. We have almost no face-to-face meetings. I've been on the board of directors for 1 year now, and there's at least one director that have not met in person. We do all the meetings over RRC and phone and stuff. All decisions in the Apache Software Foundation are made on mailing lists. And, this is really a recipe for failure. You're working with people from different countries, different backgrounds, different languages. This could not work, and it works. We're pumping out tens of releases every year. Some of our projects are industry standards, HTTP server, Hadoop, you've probably heard of these projects. And so it really works for us. Using these tools, and we'll try to explain you what is the secret sauce, what makes a difference in the way you use these tools. Some of you might have tried to introduce these tools in your company, and many people tell me it didn't work. People didn't buy it, and it brought us nowhere. So can we define requirements for a set of collaboration tools? I'm not talking about the specific tools. Is Jira better than Bugzilla? Okay, Bugzilla is ugly, but it works. And it doesn't really matter which exact tool you use. But over the years, I've come to realize that there are a few things that make the difference. This guy would like to be an Apache guy when he grows up, and how do we get him from here to there? So it's not really a set of requirements that we'll define. I'm not going to do, 1, 2, 3, 4 requirements and so on, but more like code drivers. Thinking about that, I've been giving this talk for about 5 years now. In the beginning, I had to explain the tools. What's Bugzilla, what's source code control, what's a version. Now, many people are aware of that. They know how it works. If not, feel free to ask questions. But we're going to talk more about the high-level things that make this work. The vision. Does your group have a common vision? It's not so obvious. Can you find out what's happening in your project? Can you find out how to help others? Can you find out why things are how they are in your project? And that's the angle that I'm taking to look at these things. First, about the vision. I'm not a big sports guy. I cycle to the office. I do some skiing like every good Swiss guy, but not really much into sports. But I love the sports analogy. Like, this team of soccer, they have to have a common vision to succeed. If they run around in all directions on the playing ground, it doesn't work. They have to know, what's our strategy? What are we trying to achieve? In soccer, it's fairly easy. We want to kill the others. But in a software project, it's a bit more subtle. So I think that's the most important thing, is to get a common vision on your team. I think it's a biblical statement that says, without a vision, my people perish. And that's pretty much true in a software project. The second driver, I think that makes all the difference, is to be able to find out what's our status right now. You're working like crazy in your project, you have deadlines, you have someone sick, someone's on vacation, you have to deliver yesterday, the boss is shouting. Where are we? Where do we stand? And things move quite fast. At Day Software, the R&D team, that's 30 people, and where you're in a crisis, that goes really fast. You see the commits flying around and everything's happening at the same time. And the manager wants to know, the one person who's signing up for delivery wants to know, where are we? Will we be finished tomorrow? What time? The customer is coming in at 10 tomorrow. Will we be finished? And it's very hard to find when things move fast. Quite similar to sports. The third driver is to be able to find out where you can help. You're in this situation. This guy is, maybe having trouble. What can I do to help him? You have to find out and decide really quickly. In a busy software project, it's pretty much the same thing. If you're all good people, or, if you have a big memory problem in your software, hopefully there's a few people who could solve that. So you have to enable these people to find out that they can help, and exactly where can they help. This is the third core driver, I think. And the last one, which is also very important, is to be able to find out, why did we do this? Why is this piece of software like that? Why do we have this weird class that looks like a workaround in the software somewhere? And to have kind of a history book of your project where people can turn to and find out this information. If you have to ask around the office, if we were all part of a team of developers and I joined this team today and I have to ask all of you about what we've been doing, this won't work. It would take me 6 months and you'll be, bugged by that. People have to be able to find this information in self-service. Go somewhere and at least find the basic information in self-service. So I think these are the 4 drivers of successful collaboration. Having common vision, having real-time updates on the status of the project, being able to make real-time help requests when something happens, and having self-service archives to find out what the history of the project and the decisions are. Now the question is, how do we do this? I hope you agree. I'm trying to be convincing. So I hope you agree about these drivers. And then if we agree, how do we implement this? And I think the Apache Software Foundation and other open source organizations, talking about the SF because it's the one I know best, but it's probably the same in other organizations, they succeed in doing that. Linux is pumping out releases like crazy and of very good quality. The SF is doing the same. So this works for us. let's go now to the details. How do we implement these things? What tools enable this, to implement these drivers? About sharing the vision, I think the most important thing is to move from I call that the mass media situation where everybody's talking to everybody. So, you have a problem about memory. That's Bob. Talk to Bob. You have a problem with the installer. Talk to Jim. Okay, so you talk to Bob and talk to Jim. Jim talks to Bob and Bob talks to Anne and Anne talks to Bobby. And then the information is not, you cannot get it. It's just floating around. Worst case, people are sending Word documents by email to each other. I hate that. That won't work. You want to move to a situation where you have a central hub for your project's communications. Somewhere that the discussions, decisions, the code stays. And people can go to that, look at it, and find out what happened and why that happened. In the SF, the tools that we have to enable that are, first and probably most important, is a searchable mailing list. When I talk to my colleagues in the Jackrabbit or the Sling project, I don't send an email to someone, send it to a central mailing list, and it is archived. So tomorrow, next week, in 4 years, I can go back and find out what the discussion was, what the argument was, and how did we come up with a solution. That's very important. So mailing list, central mailing list, and archives, searchable archives. Wikis are also good for that, a central place where you can create documents. That also helps fulfill this sharing of vision. And the blogs are really good, the blogs or Twitter, whatever you want to use today. They are good because they are for out-of-band discussions. You can post something on your blog that is not directly related to the project, and it doesn't necessarily bother people. They're free to look at it if they want. Whereas on the mailing list, everybody has to see the message. So blogs also help a lot. These are the 3 tools that we use to share the vision. For the real-time updates, being able to find out what's going on in a project, the thing is that we need fast feedback. When you're doing, BMX, mountain biking, windsurfing, especially if you ride a bike like this one, you need very good and fast feedback. I hope you don't drive when you're drunk. If you do that, it doesn't really work because your feedback is slower. The bike starts going to the left, it's going to the left. It doesn't work. You need very fast feedback loop for these things to work. And I think we need the same thing in the code. And we can do that. If you're working in an open source project, when I commit something in Slang, the other committers can see that within a minute and maybe see, Bertrand, that doesn't work. What you did, we need to change that. Fast feedback. I'm still doing that. I can fix it right now instead of waiting 2 months. The feedback loop, it goes from the developer, create code. Maybe there's a user that tests the code, reports to the manager. Manager gives feedback to the developer. There might be a big chain here if you're a big company. How fast is your loop? Mark was talking about the problems with the iPhone software, where you need to do an update, you might need weeks. This is very bad, because if you did something wrong in your code, you'll find out weeks later. You don't remember what you were doing, you're doing something else. We really want to have a fast loop here. It can be seconds if you have the right tools and you use them in the right way. The way we do this in the Apache Software Foundation is everything that we create code, create test code, we create, we don't create bugs. We create bug reports, when you describe an issue. We make decisions on our mailing list. The builds happen because we have automated build systems. All this information goes into a central communication hub in the Apache infrastructure. It's not really integrated. It's kind of a disparate hub with mailing lists, RSS feeds. We even have Twitter for infrastructure. You can subscribe to a Twitter account to be informed of what happens. And then you subscribe to what you want. People are free to subscribe or not. You can decide to follow a project or unfollow for a few weeks because you're not working on that. But if you subscribe, you will get events really quickly when something happens. And if there's a developer in the team that's working on a memory leak issue, they're not very good at that, you might watch them. Set a filter on a mailing list. When this guy commits something in this module, I want to be informed of that. So you're going to set up all kinds of filters. I get probably, I don't know, 300 emails a day, due to being subscribed to the various mailing list events and stuff. So you need a good filtering strategy to cope with that. I'm not reading them, all of them every day, but I'm filtering them to find out what's important. But this allows you to have these real-time updates and find out really what's going on in your project. So first thing is to use a source code control system. Instead of having code on the file server somewhere, I hope nobody of you does that if you're developing software. That shouldn't happen today. So a source code control system will generate events when something happens, commits, for example. We use an issue tracker. Instead of asking people, what did you do today? You look into the issue tracker. And this will tell you, oh, he worked on this issue, close this one, create another one. That's very efficient. We use mailing list events. Instead of yelling around the office, you post a message to a mailing list, maybe with a special subject that says help or important, vote, something to kind of tag your messages. And we use automated builds. Instead of waiting for someone to do the build on Linux, we have a machine do that. We have computers, should use them. So all these things generate events that allow us to shorten the feedback loop and to find out as quickly as possible when something is not working in our project. I'm going a bit fast. Normally I do this talk in 40 minutes. I have 30, so I'm squeezing 10 minutes into this time. If you have questions, don't hesitate to I think it's possible to interrupt, yes? Yeah. Or after. Okay, so better keep the questions for the end. How do we implement the real-time help thing? How can I call for help to my project co-workers and vice versa? A help request, feature, enhancement, bug, is a dialogue. Someone asks for something, I put manager, developer, can be 2 developers, whatever, doesn't matter. But it's not just, I ask and things happen. I ask and someone will say, oh, what did you mean? And I think you can do it like that or like that and so on. So it's conversation until you reach a point where the feature is implemented. And it's very good to keep track of this because it allows you to go back later, 5 years later, find out, oh, this is why we did this thing. And this can also be real time if you have an event here. So what we use in the ASF and most open source projects work like that is to use an issue tracking tool, like Bugzilla or Jara or Track, there are many of them, where you have 1 page per issue. So when you have a problem, you say, I just found a memory leak problem in my software, I will create a new issue, it gets a unique number, very convenient to know what we're talking about, and then you can see the list of issue, and these are real-time help requests. Someone can subscribe to a feed of this page and be informed immediately that someone made a request for help. And then if you're 10 developers, you can go on this list and every one of you takes 1 issue, assigns it to themselves, so you can also split the work very easily. So this is really the tool that helps us implement the real-time help. You use an issue tracker instead of just asking Bob to fix this. Even if you were working in the same office as Bob, it's a really good idea to use the issue tracker. A rule that I set in my teams is that if you're working on something, it must be an issue from the tracker. If I'm asking you, what are you doing? You must not say, I'm working on the memory problem that Bob reported last week. No, that's not what I want. I want you to say, sling-1234. Oh, that's the number of the issue. You want to know what it's about? Go look. Okay, I can explain to you if you need, but the basic info should be, I'm working on this issue. This makes the whole difference in managing your team. In a crisis, you can also reassign the priorities on the issues very quickly and split them among yourself. Talk to the customer. Do you really need Sling 1234 in the product tomorrow at 10? Customer say, oh, okay. Now, if we can have the other feature, I'll drop this one. So you can reassign, reshuffle the priorities very quickly. Makes a whole difference in this real-time calls for help. The last driver that I mentioned is those SelfService Archives, the big book of history about your project. And the thing is that when you're working in a busy team, there's no time to document everything that happens. Some people say, yeah, but we'll have time later. When the crisis is over, we will go back and do the documentation. Who does that? Anybody work? Okay, if you're working on space shuttles, maybe you will do that. I'm not, and many people are not working on space shuttles. Then what happens is we work like crazy, and the information is lost because we don't document it. Yet, if you have new project members, little birds coming into your project, they need information in self-service mode. If they have to ask everybody, I tend to forget everything that I do because I need to focus on the new things, and it's boring. So you really want people to be able to find this information in self-service mode. How do we do this in the Apache Software Foundation and inside my company? The source code control system also helps a lot in that because it keeps logs. You can trace the code, find who wrote this line of code and when. Then you can ask very precise questions to people if you need to. The issue tracker data is structured and searchable. You have one page per issue. You can put tags on the issues, assign them to components. The searching is very precise, very efficient. So that helps you find out what happened. You can also link the source code control to the issue tracker. When you commit some code, you say, oh, this is code for sling-1234, then people can see the details in the tracker. Try to create links between these tools. The mailing lists are also semi-structured and somewhat searchable. The search is not very precise on the mailing list, but it works, more or less. You might have to spend a bit more time to find, but you will find eventually, hopefully. Depends also how you use them, so you need to tune the way in which you structure your messages. The basic rule is one question per message, like in any email, but that will help you find the information later. The blogs and the wikis, they stay around. If I write something on my blog, 5 years later I can go back and give the URL to people and they will find it very precisely. So that's also a way of creating this history of the project that people can, browse and find out what was happening. It's very important when you use these tools to speak in URLs. When I'm talking of something, if you look at the emails that I wrote to the Apache projects, I'm always using URLs all the time. I'm not the only one, but it's very good to do that. Like, if you talk about the memory problem that we found in the Blastalizer module last week, it's not very precise what it is. If you put this URL in your mail, or in your issue, or in your code, people know exactly what you're talking about. They can go to the issue and have all the details. So speak in URLs. Same thing for the mail archive. If you want to make a reference to a mail, you can just point to it with a URL. It will also help Google index it if your project is public, or create links between information. So this is one best practice that's very important. Always indicate the URLs of the things that you're talking about. Are we there yet? Do we fulfill those criteria? Do we have shared vision, updates, help, archives? I made a little kind of table that shows how the tools that we use enable this. So for the shared vision, we have the mailing list and archives, the wikis, the blogs. For the real-time updates, source code control system sends events, issue tracker sends events, mailing lists, obviously there are events, each mail, each message is an event, and continuous integration, the thing that builds your software, can tell you using RSS feeds or events or Twitter, whatever, the build succeeded, the build failed, so also events. That gives you updates on where you stand now. The real-time help requests are really mostly the issue tracker. You can also use the mailing list for that, but the issue tracker is much more powerful, much more structured. And the archives, basically all the tools participate in creating the archives. And I put the instant messaging and IRC in extra tools. They are useful. They don't really bring much value to that. And in the Apache Software Foundation, for example, those are frowned upon to make project decisions. We say to people, you don't do any decisions in IM or IRC, or if you're about to do a decision, you go back to the mailing list, and every decision must happen on the mailing list by a vote or something like that. So it allows us to know where to look for decisions. Some other projects work differently, that there's not only one way. So this works for the Apache Foundation. I think, it's obvious that the Apache Foundation is working. Maybe not all projects every time, but in general, it's working quite well. What about my team? We need a migration path to go from the chaotic and structured way of working to the happy developers sharing a central communication hub. If you try to throw all the tools at these people in one go, guess what happens? It doesn't work. It's too much to swallow in one time. We need a migration plan, stepwise plan to reach this state of development group nirvana. I'm going to suggest one plan. There might be others. In my opinion, this looks like a cheap ad, and it is actually. In my opinion, the most important thing is to have a source code control system. If you're developing software without a source code control system, this is 2009, come on. You have to use that. It's a basic tool that everybody should use today. I'm very scared that in our schools, many students are not exposed to that. I used to teach, and I was teaching people to use CVS at the time, and they had never heard of that. So if you're a teacher or student, go and tell these guys that they have to learn that. Commit early, commit often. Don't hide your stuff. We'll talk a bit more about that. And whatever's not in the source code repository does not exist. You might have sometimes a big video file that needs to go somewhere else, but that should be an exception. So this is really the most important tool. Which tool you use does not really matter. If it's a version, Git, CVS, Mercurial, doesn't make a big difference. The important thing is to use one. Second step that I suggest is the issue tracker. We'll bring structure to the questions, status questions. It will document the main micro decisions that shape your project. You make tons of decisions when you write software. If you document these decisions a bit, just 1 line, 2 lines, it's good. You will be able to find out a few years later. Review and update priorities, like I said before, in a crisis. You can shuffle this list very quickly and really find out what do we need to do now to overcome our crisis. So this would be my suggestion for a second step. Then third step would be to have automated builds and repeatable, instead. If you tell people, just configure your Eclipse like mine, that usually fails in a big group. So you need to have repeatable builds like using Maven or Ant if you're doing Java or Make or whatever. There are many build tools. You need to use them. If you can go to continuous integration, automated builds all the time, this will be faster. Using Maven or Hudson or Ivy, whatever tool, doesn't really matter, but have a continuous loop of integration. Then the next steps, that's pretty much open depending on the shape of your group. Archive discussions are important. Wikis and blogs, encourage your people to blog internally, publicly, whatever. Instant messaging, RLC, Twitter, SME, it's a cool new project in the ASF. They are very useful, but I think they are less impact on the overall way of working. These tools mostly replace the telephone in a good way sometimes, and then sometimes in a bad way, so you have to choose, but they don't make as big a difference as the other tools. Does this work? It can work. You have to not force things on people, do small steps, and get the team's acceptance on every step. And one thing that I recently realized is that for many people, the thing that makes this not work is the fear of making mistakes in public. If you're committing early code, it might be crappy code. People will tell you, hey, your code is crap. The first time they do that, it hurts. And once you get used to it, you say, okay, I know my code is crap sometimes, and sometimes your code is crap, and we talk openly about it, and we're happy. So I think this is something that you need to overcome. I'm living proof that this does not kill. If you go into the Apache archives, you'll find lots of mistakes that I did in 10 years, including saying silly things, very silly things. I'm here. I'm happy. I'm a member of the board of directors. They even elected me despite all my mistakes, probably because I learned early on to do mistakes in public and not feel too bad about it. Nobody's perfect. So I think that's a very important factor in training your team to work in this open way. Conclusions. I have 1 minute and 10 seconds to do that. Will work. The main conclusion is that this works. The Apache Software Foundation is a living public example of that. Day Software is a living, a bit more discrete example because we do that internally, but we try to expose that on our blogs. It's important to focus on the goals, these 4 things. Enable these things. Whatever tool you use does not really matter. If you have a tool that allows you to get a common vision better, do that. If it's videos floating around the company or broadcasts or weekly meetings, Scrum calls, that kind of thing, no problem. The source code control system is the most important tool in my opinion. Issue tracker comes next, and then the other tools are less important, and you can introduce them slowly as your team starts to understand these things. So that's it. I'm finishing 45 seconds early, sorry. So I'm open for questions. I'll be here the afternoon, so if you have more questions, we can also talk later, but general questions now.
Thank you very much. If you have questions, please speak in the microphone and say quick who you are so we can record it.
No questions means either I was too clear or too boring and you all fall asleep.
Do you use documentation directly into the code, like Javadoc or something like this?
Yeah, that's a good question. Documentation in the code, that's one of my dreams. We are using some of that, like trying to have good Javadocs, but even Javadocs can get out of sync. You know, you have this function doing something, and you document it in a Javadoc, then you modify the code, and no one updates the Javadoc, so Javadoc is stale. You have a good chance because it's close to the code to make it better. My current dream, I have many dreams, but professional dreams. I also have other dreams that I won't tell you about. My current professional dream is to have the test code be the documentation. Write very readable test code and maybe some kind of literal programming where the test code really gives the reference information. Then if the test run, you know they're right, and then this could be used for documentation. I'm exploring this right now. So in the projects, we are using Javadoc, we are using readable tests, but we want to make this even better and try to really generate the reference documentation out of the test.
How do you ensure that the issues that get filed do not collect dust, but actually get somebody to work on them?
So when an issue is filed, how do you make sure that someone's going to work on it? That's your question, yeah. So this is something that the product manager must review from time to time. Someone, it can be a developer, but someone has to take the role of the product manager and from time to time go through the issues and look at them and say, hey, we forgot about that one. If it's an open source project, people will usually complain. Someone say, hey, I created an issue in Sling 8 months ago, it's still not fixed. Could someone do something about it? But otherwise, you need to go through the list of issues from time to time and review it, maybe up the priority of some issue. You really need to do that. And if you don't do that often enough, it can get very hard. If you get to 500 open issues which are not resolved, and some of them are 8 years old, that can be a problem. So you have to do that regularly.
So first of all, thanks for the interesting speech. You said that the tools we are really using, they don't matter that much as long as we are using them. So we just recently evaluated lots of tools in terms of issue tracking and source code repositories, and there are big, huge differences.
Yeah.
Is there some shared knowledge around? Does the Apache Software Foundation provide knowledge to this?
Yeah. So about exactly which tool to use. So if you're using non-distributed source code control, I think it's clearly Subversion today. That's the best tool. It's free. It's very good, etc. So very well known. If you want to use Git, it's a different way of working. Distributed source code control, which is very good. We cannot use it right now in the Apache Software Foundation officially because we need to be able to trace the code to exactly the person who wrote it in a cryptographically or password-safe way. And Git doesn't, as far as I know, Git doesn't really allow that right now. So we're working on that. I expect Git to make a big difference in the way the SF works, or sizable difference. So I would say these are the two in terms of source code control. At the SF, we have Jara and Bugzilla. Within Day, we still use Bugzilla, which is very ugly, but it works for us. I prefer Jara much more, even if it's not really open, but it works pretty good. I've heard very good experiences with Track. And Track has the advantage of having some form of integrated wiki, which has good links to the issues. So I think these are the three that I would mention. For the mailing list archives, as I was mentioning, MarkMail, which is probably the best archive of Apache mail that we have now. I think they have a commercial product that you have to buy to install in your company. So that the open products are the, I think EasyMLM has some search features, I'm not sure. But it's a bit more fuzzy in this direction.
Thank you for your presentation. Okay, and you have covered the source control and issue tracker problem, but I didn't find the testing phase that is very important in continuous integration, and in special way, what kind of tool, what kind of procedure you use, or your experience
for testing.
Yeah.
So how do we test our software? So in the SF, it differs from project to project because the 60 projects, they are pretty much free to organize themselves how they want. I'm more in the Java camp, so I know more the projects from the Java side, Cocoon, Jackrabbit, Solar, Sling. They are the projects that I know best. In all these projects, we use Java, the standard Java testing tools, JUnit or TestNG, that kind of stuff, integrated in a build. So when you run the build fails if the tests fail. So this is the only way to make sure that your tests really pass. And then we have a continuous integration service, which will run these tests all the time and send events if the build goes from pass to fail, which allows you to find out. So basically the tests are an integral part of the code. You can also write integration tests like that. It's a bit harder, but you can do that if it's web applications. And basically the tests are just alongside the code, and the build fails if the tests fail. And you can disable that when temporarily, if you're working, you might need to disable the test for some time. But there is a continuous integration server that does run the tests all the time.
Okay, thank you. I must quit here.
Okay, we
Time
can talk
is
later.
over. Yeah, I think you're around here when you have further questions. So, thank you.
You're welcome.